All right. Thank you for sticking around for our guest speaker we're going to have in just a moment. But first, a couple of reminders. We are going to be going to Sydney in the next summit, November 6th through the 8th. So save the date. Gorgeous city. It's just around the corner. I can't believe we do these twice a year, and how all of a sudden we're already planning the next one. And then after Sydney, we're going back to Vancouver, which is one of the most amazing places we've been able to have a summit yet. All right, so save those dates, and we will see you there. But before we leave today, I've got a very special guest that I'm excited to have an opportunity to interview. So let's bring out Edward Snowden on the big screen. Welcome to your first, but hopefully not your last opportunity to join the OpenStack Summit. Sorry you couldn't be here in person. We will try to get you a T-shirt if we can. Are we getting the audio? Yes. Okay. All right.
This is an audio check. Can you hear me?
Yes. Okay. Everybody can hear you. So what you've got here in the OpenStack Summit is thousands of people who are really concerned about cloud computing, building cloud computing, running clouds. And so they're from all over the world, 60 plus countries. And what is your kind of take on cloud computing, and what does that mean from your point of view?
So, there's a lot of different ways we can look at this. One is the abstract sense, where the ordinary user, how do they think about cloud? What does cloud mean to them? To them, cloud means, Google Apps, Gmail, things like that. They've got things up on somebody else's computer. On the other hand, we have what you guys do, and sort of the infrastructure as a service layer, which are really increasingly becoming the bones of the internet, the thing that we build upon. And I think one of the most dangerous things that we see happening in this space, and one of the things that you guys do best, is help the people who are placed to actually make the decisions about how to build, right? Make these in a considered way. For most people, the internet is kind of magic. It just happens. They look at it on their smartphone. Their Facebook app is the internet, right? But that's not enough. And we can't actually let people go to this mindlessly, effortlessly, when they're in the act of building rather than consuming. And it raises the question of why, right? Particularly when there are these sort of primarily for-profit alternatives when we get to the infrastructure as a service layer. You could use EC2, you could use Google's compute engine or whatever. And these are fine, right? They work. But the problem here is that they're fundamentally disempowering. You give them money, right? And in exchange, you're supposed to be provided with a service. And that exists, right? But you're actually providing them more than money. You're also providing them your data, and you're giving up control. You're giving up influence. You can't reshape their infrastructure. They're not going to change things and tailor it for your needs. And you end up reaching a certain point where, okay, these are portable to a certain extent. You can containerize things and ship them around. But you're sinking costs into an infrastructure that is not yours, fundamentally. What OpenStack does, right, it makes you lose that fundamental, inherent, silent vulnerability of investing into things that you do not influence, that you do not own, that you do not control, that you do not even shape. Whereas with OpenStack, you build it layer by layer. It requires a little bit more of a technical understanding. But as it's becoming more sophisticated, and as it continues to comply with this very free and open set of values that the open source community in general drives all over the place, but particularly here, we can start to envision a world where cloud infrastructures, right, are not private in the sense of private corporations, but private in the sense of personal, right? Whether you are a small business, whether you are a large business, whether you're a community of technologists, you can own it, you can control it, you can shape it, right? You can build, you can lay the foundation upon which everybody builds. And I think that's probably one of the most powerful ideas that shapes the history of the internet, and hopefully will allow us to direct the future of the internet in a more free rather than more closed way.
Thank you. That's an insightful answer. I think that we did ask on Twitter for suggestions. We got a lot of suggestions for questions. A lot of them were obviously in the realm of open source. We're all open source stackers here. And some of them, asked just for a little bit of background on your experience with open source. What projects do you use or have you experienced with? So kind of, what's in your toolbox open source wise?
So probably my most famous involvement has been during the NSA revelations of 2013, which people don't really think about too much in depth because, the NSA is primarily running on a Windows infrastructure, right? They have Linux machines, they've got servers and things like that to do that. For the NSA and the CIA, we've seen quite recently through like the Vault 7 leaks and the Shadow Brokers leaks, that there are also very aggressive GPL violators in the intelligence community. But on the
we have a lot of licensing geeks
sort of
here that are
side,
interested to hear that.
There's this journalistic side, right? How did we actually make this happen? How did we effectuate the return of public information to public hands that revealed sort of unlawful activity, unconstitutional activity, the violation of rights or norms or laws? And this was almost entirely powered by open source, right? The Tor guards that I was going through, I stood up myself. They were running on Debian. We're using, all the journalists were using Tails, the Tails project as their interfaces, because I wanted to limit the amount of mistakes they could make. They were learning on the fly. Nobody had seen this. And of course, they weren't specialists in this. And the Tor project, was really the most critical piece for helping people. It's not to say it'll secure everyone from everything forever, but it gave them enough breathing room to make things happen. Now, since then, I was elected by the board as a director at Freedom of the Press Foundation. Now I have become the president of the Freedom of the Press Foundation. And my primary work there since joining has actually been expanding the open source development efforts that we have in-house there. Of course, we make SecureDrop, which is run at all the major important newsrooms in the United States and increasingly around the world now, for allowing sort of anonymous sources to contact journalists securely. But there are a lot of other really interesting efforts that you'll be hearing about more this year. One of them, for people that are interested in sort of open hardware space, is last year I gave a talk with Andrew Bunny Huang at the MIT's Forbidden Research Conference on what we call an introspection engine for modern smartphone. We're targeting the iPhone 6 here. And this gets into that central issue that we sort of talked again about with infrastructure, is you're running things on Google's stack, you're running things on Amazon's stack. How do you know when it starts spying on you? How do you know when your image has been passed to some adversarial group, right? Whether it's just taken by an employee and sold to a competitor, whether it's taken, copied for the FBI, whether legally or illegally, right? You really don't have any awareness of this because it's happening at a layer that's hidden from you. It doesn't matter whether it's rootkit, doesn't matter whether it's hypervisor, doesn't matter whether it's just a process stack. The same thing happens with our phones, right? When we turn on airplane mode, when we turn off location services, how do we know the GPS is actually off? How do we know the baseband antenna is actually powered down? We're trusting a software attestation, and a rootkit can make that lie to you. So we're developing a hardware, which is free and open. Anybody will be able to replicate this. We're going to provide the plans. We've already written the paper about it, where you will be able to actually look at the electron flow over these circuit paths to confirm that for yourself.
Wow, okay, that's great that you're driving forward into open source in some meaningful ways. Appreciate you sharing that. I think, Another theme that I heard from asking for questions out there in our community was, for those of us who are working on open technologies, what are some of the ethical implications or obligations that people have if they're working on something, not knowing necessarily how it might get used and maybe in ways that they don't necessarily agree with personally?
Think beyond what the license says is clearly lesson number one from this year. That stuff matters. The capability matters. And we have to recognize that, all government involvement isn't necessarily a bad thing, right? All intelligence agencies aren't necessarily bad either. There's a lot of good people at NSA. There's a lot of good people even at CIA. It's hard to say it, but there's even some good people at the FBI. And the idea here is we want to enable everybody, right? But we want to think about the context and meaning of our work as technologists. Fundamentally, we don't work for governments. We don't work for states. We don't work for corporations. We should be working for the spirit of technology itself, moving people closer to a more empowered future. I try to think of this in terms of values, right? All systems should largely be designed to obey the user. And secondly, they should not be designed to hide things from the user. They should not deceive the user. They should not lie to the user. And they shouldn't hide things material from the user. This is one of the largest problems that we have with closed source. It's not so much that somebody doesn't want to share source code, although that matters in the abstract sense. It's what that actually means when they don't. That leads to the world that we have today, where we've got vulnerabilities in every Intel chip that has AMT enabled and things like this, because Intel's monitoring engine, excuse me, Intel's management engine has these blobs on it that we can't inspect, that we can't see, that we can't change, that we can't patch ourselves. When you're thinking about your ethical obligations, the main thing is, how do I empower the user? And if this creates a large-scale disruption in traditional power structures, right? If this can be used, or an amplification of powers that are used by sort of aggressive actors, whether they're corporate, whether they're government entities or anything else, how can people be sheltered against this, right? At least enter that chain of thought and think about what you can do to protect people. The traditional world we like to think about of the happy policeman on the street that's looking out for people is increasingly, and some would say tragically, being displaced by technology, because we can only put so many people in so many places, but technology is everywhere. And if we are going to have a computer in every home, in every pocket, in every car, in every place, we need to make sure that they are living by the values that protect and serve the public.
Thank you. I think that's interesting insight. And the next question that I wanted to ask was really just about kind of the dynamics of exploit. So, there are people now that'll pay $1 million for a zero-day exploit. Various actors. There's a market for it. So how does that, the sort of economics of it, affect the dynamics here out there for people that are trying to secure their infrastructure?
This is a complicated space, and it's hard to get in here in the short time that we have, because we could spend an hour just on this topic. But to look at it briefly, mitigations work. We know that. If you can start to move entire bug classes off the table, start using memory-safe languages and things like that for development, sort of best practices for coding standards, for design standards, to limit the kind of weaknesses that you have, that you're validating inputs and things like that. This will make attacks much more expensive, but there's still going to be that market out there. There's still going to be people that are looking for that, and they're still going to succeed. Now, traditionally, we've said the beauty of open source is that many eyes make all bugs shallow, but we see the bugs still get through. And they still get through for a very long time, even in the most open context. We get things like shell shock, right? And then the impacts of this are large. But that's not actually an argument that we shouldn't do open source, is that some bugs get through. The beauty of it is that when something like that does come through, just as we get all of these bugs all the time in these closed source ecosystems, even iOS has jailbreaks and things like that fairly routinely. And they have actually a quite skilled security team. The entire community can respond, and they do, right? When a shell shock type bug is discovered, everybody looks at that code base, right? And it gets improved in more ways than just that. It gets more people involved in the process. We don't want to encourage or look for these big bugs to hit us, right? And then be like, oh, great, we had a wonderful response afterwards. But the fact that we can is fundamentally empowering, and it's fundamentally educational. We learn from it, we improve as a community. When Apple has a security flaw, when Google has a security flaw, when Amazon's stack, or even not in their fundamental programming thing, but just in their processes, their employees are clicking on phishing emails, their keys are stored on a staging server, and somebody can get in and pop that and move laterally, and now they've got the keys to the kingdom. We don't know what they learned. We can't evaluate if their response was positive or negative, if it was good enough or not good enough. And ultimately, even if we don't like it, we have no influence over it. Now, people might go boo-hoo. That's sort of how private industry works. And that's a fair argument, right? But the point of open source is that we have a better one. We don't have to compromise. We want a better world, and so we're here to build it.
Okay, well, that brings me to my next question, which is, I think they're ready to build a better world. So you've got the right audience here. So my next question is, looking forward, with everything you've seen, everything you know, are you an optimist or a pessimist or somewhere in between at this point?
Depends on the day. I am fundamentally optimistic. When you look at where we are in the progress of technology, we are at a crossroads. We have been struck by a moral dilemma that we did not ask for, that we did not seek. The way I've described this before is, this is the atomic moment for the profession of computer scientists, right? In the last century, we had nuclear physicists who were looking at the science. They were trying to master the fundamental laws of the universe, just how this stuff fits together, and they wanted to see how far they could go. They discovered some new means of productivity, right? This incredible energetic potential. That's what the internet is today. The problem is we did not predict how bad actors, aggressive, violent actors, would apply these discoveries of ours. Now we need to think about how we can mitigate them. We can't put the genie back in the bottle, right? We can't unsplit the atom. But what we can do is make sure that we don't make the same errors that we made in the last century, where just to make sure something's working, just to make sure that our cell phone network works, we adopt terrible standards like sort of this SS7 sort of circuit switching system for cell phones, where it can be hijacked from all over the world, where we have the weakest possible encryption schemes that could possibly be applied to typical cell phone communications, because governments actually encouraged the adoption of that. They wanted them to be weak enough to break. They didn't say that was why, but we need to make sure that we're not looking at good enough, particularly not good enough for now, because it's very hard to update the technology. It's very hard to move legacy stuff out of production. We all know that, everybody sitting in the room. We need to start thinking about how to build not just for today, but for the next 100 years, by setting an example and by setting protocols that say, we're going to build things not for today, we're going to build things for beyond tomorrow.
Thank you. Well, we've got one final question. One final question from the audience, getting slightly more political. Well, what can we do this person asked, to reverse the trend of protectionism and nationalism? It's a pretty heavy topic.
This is extremely complex. When you look at the political dynamics today, whether it's the election in the United States, the closeness of the election in France, laws that we see being passed in the United Kingdom. They passed the most extreme surveillance bill in the history of Western democracy last year, called the Investigatory Powers Bill. In places like Russia, we see laws like the Yarovaya Paket, it's called here. Russians call it simply the Big Brother law. And when Russians are calling a surveillance law the Big Brother law, you know there's a problem. Fear has become the most common political value in the world. Saying, but terrorism will defang any opposition, it will silence any counter proposals, and this puts us in a systemically vulnerable place where the traditional systems of checks and balances upon which Western civilization has relied upon, particularly since the democratic process sort of spread around the world, are starting to fail. Courts are afraid to rule in areas that are politically controversial, even though they are legally quite clear. For example, all this mass surveillance in the United States is a pretty clear violation of the Fourth Amendment. Any sort of expert group like the ACLU that looks at this is filing cases about it. And the courts are very hesitant. They work these things through the appeals process about on a 10-year span because they don't want to be seen as simply applying the law in the way that makes sense and the way that would restrict the government in the way that it traditionally has, because judges are people too, right? Judges are vulnerable to fear in the same way everybody else is. Politicians are vulnerable to fear in the same way everybody else is. Presidents are vulnerable to fear in the same way. And this creates a world in which the weakest link in the fabric of the safeguards of our rights is increasingly becoming human. Now, this leaves us in a place where the traditional mechanisms of enforcing human rights are beginning to fail. So we have to develop new ones. The beautiful thing is, at the same time these old processes are beginning to fail, technology, we're seeing glimpses where it can enforce human rights in new ways beyond borders, right? Let's say you have a country that doesn't respect human rights as well as the global standard, right? This doesn't have to be a place like South Sudan or Cameroon or Russia or China. This can be a place like the United Kingdom. This can be a place like France. This can be a place like right here in the United States, in Boston. But if we develop protocols, systems that are invisibly surrounding us every day, they're in our pockets, right? Even if somebody doesn't touch the internet personally, their communications are transiting the internet. They're relying upon this fabric that we built, this mesh, whether it's the infrastructure that you're providing that a hospital is putting their records on, right? That a 90-year-old woman who doesn't even have a computer is still relying on. These same things can be pushed across borders instantly. And when we create safe and reliable means of protecting human rights, right, at the protocol level, at the system level, where rights can't be abrogated simply because it was convenient or simply because someone asked, we create not just a better world, we create a freer world. And it can happen on every corner of the earth as fast as we can proliferate the technology. And I would argue not only that we can do this, not only that we should do this, but if the next generation is to enjoy the same rights that we ourselves inherited, we must.
Thank you so much, Edward Snowden, for joining us at the OpenStack Summit. And I would like to go ahead and invite you to the next summit in Sydney and all the other summits from here on out. We really hope you can come back and talk to the community again. Thank you so much for your time.
Thank you.
Well, folks, that's all we've got for this morning's keynotes. I hope that was interesting for everybody. I know I enjoyed it. But as you leave, be sure to remember our maxim: have a good time with OpenStack.